Right, so second of our calculation videos is going to be looking at moles. First question is technically not moles, it's law of conservation of mass, but I've lumped them in here together. So I've got an equation: calcium carbonate decomposes to form calcium oxide and CO2. You're told you're starting with 10 grams of calcium carbonate. You were told that you end up with 8 grams of calcium oxide. They want to know how much CO2 you have. Because of the law of conservation of mass, if you start with 10 grams of reactants, you must end up with 10 grams of product. You're told you have 8 grams of calcium oxide, therefore CO2 must be 2 grams so that the two sides are equal. These questions are typically just 1 mark and you'll be given 2 masses in your question. The next question though, you're given calcium carbonate again. You're told you're starting off with 10 grams. You're asked how much you're going to get of the CO2, but you're not told anything about the calcium carbonate. Without being told how much how much calcium oxide you're making, you're not going to be able to figure out how much carbon dioxide you're making without using a moles table. So you'd have to use a moles table when you're only given 1 mass and you're asked to find the mass of something else. And similarly, this question can also look like this. They tell you you're trying to make 2 grams of carbon dioxide. They want to know how much calcium carbonate are you starting with. Again, if they only give you 1 mass, then you're going to need to do a moles table to work it out. So we'll just have a look at some examples. So we're going to go into the exam questions. I'm actually going to start on question 14, but I will go back to the other questions in a minute. You're told you've got 8 grams of calcium carbonate. You're told you've got 6.213 grams of this solid. You're asked about CO2. When you're given 2 masses, it's much easier. You'll see it's only a 1 mark question. It's just going to be 8 minus 6.213 to work out how much CO2 you've got, because the reactants and the products must both equal 8. In the next question though, you'll see you're only given 1 mass, not 2, so you're going to need to use a moles table. So when you're using your moles table, you're always going to include 2 things. You're going to include the formula of the compound that you're given information about. So you're told you've got 135 grams of this carbohydrate. You need to work out which one of these is the carbohydrate they're talking about. As a clue, if you look at the other information they give you, they tell you the formula mass of CO2 and they tell you the formula mass of C6H12O6. That tells you it's important and it is the carbohydrate. So hopefully you recognize it from biology as being the formula of glucose. Glucose is a sugar, sugar is a carbohydrate. So I'm going to put glucose in my table because I'm given information about it, and I'm asked about carbon dioxide, so I put carbon dioxide in my table. Okay, I'm not given information or asked about this, so I'm going to leave it out completely. Once I've decided what goes in my table, I do G Mr. moles down the side, and at the bottom I've got ratio. The mass of the carbohydrate you're told is 135. The formula mass you're told is 180. To find moles, it's mass divided by formula mass, which is going to be 0.75. Ratio I get from a balanced chemical equation. There's no number in front of glucose, so the ratio is 1. There's a big 2 in front of CO2, therefore the ratio is 2. This shows me that the number on the right-hand side needs to be twice as big as the number on the left, so I'm going to need to times 0.25 by 2. I'm going to get an answer of 1.5. I can fill in the formula mass of CO2. It's given to me in the question, 44. And then it's going to be 1.5 times 44, which is 66. And that's my answer. So I'm dividing, using the ratio, multiplying. By laying it all out in the table, it's super clear. Common mistake made by students, they use the big numbers, the balancing numbers for formula mass. Don't do that. We use the balancing numbers for ratio. We do not use them for formula mass. Next question, something similar. I've already started it. Okay, I know there's kind of lots of information in this one, but it's the same process. Okay, you're given hydrated copper sulfate. That just means copper sulfate with water, and you're asked to calculate the mass of hydrated copper sulfate that was heated. I'm going to fill the formula for hydrated copper sulfate straight into my table. Because it's hydrated, I do need to keep that H2O. And again, if in doubt, look at the information they've given you. If they're giving you the formula mass of all this, then you just fill that formula straight into your table. They give you the mass of water formed. So water is the other thing that's important, and I pop that into my table too. I'm told I've got 4.5 grams of water. I can work out the formula mass of water using these numbers here. So there's 2 hydrogens, which gives me 2, and plus 16 for oxygen gives me 18. That it's divide first. So 4.5 divided by 18 is 0.25. My ratio, there's a big 5 in front of the H2O. There's nothing in front of the CuSO4. So it's a 5:1. The number on the left is therefore 5 times smaller than the number on the right. So to keep the same ratio, I do 0.25 divided by 5, and I end up with 0.05. The formula mass for this is 249.5. Again, I'm giving it in the question, and then to finish it, I'm just multiplying, and I get an answer of 12.475. I've marked this one before, and the common mistake here was just not putting this full formula into the table, okay, and trying to work out the formula mass of just copper sulfate instead. If you're given this in the question, you're going to need to use it. Next question is similar. So again, I've just done this one, okay. You're asked to calculate the minimum mass of sucrose, okay, because they ask me about sucrose. I fill that into my table. Needed to produce 26.9 grams of ethanol. So you're going to need to work out which one of these is ethanol, okay? Even if you don't recognize ethanol, you should know that it's not H2O and it's not CO2, so it must be this. Again, if in doubt, look what they give you. They give you the formula mass of this, therefore you need to use it. So these are the two things in my table. I'm given 26.9 as my mass of ethanol. I'm given 46 as my formula mass. So I do mass divided by formula mass is moles. My ratio, there's a big 4 in front of ethanol on my table. There's nothing in front of sucrose, so a 4:1 ratio. Therefore, I take this number, divided by 4. The formula mass of sucrose I'm given, I multiply these two numbers, and I get 50, okay? Notice here when you're calculating moles, it's not going to work out nicely in your calculator. You'll get a long answer, 7, 8 decimal places. Don't round, okay? You can't round until the very end. So I've written this down to 5 decimal places, but I didn't clear my calculator. I had the full number in my calculator when I divided it by 4. And the answer I got, I wrote it down to 5 decimal places. But again, I didn't clear my calculator when I multiplied it by 342. Okay, so I'm getting the most accurate answer possible. I think it works out as 49.99, which at the very end I round to 50. But if you look at the mark scheme, you'll get the mark for 50 or 49.99. If you round it too early here, back to 1 or 2 decimal places, you're not going to get the right answer. So don't round until the very end. Next question is again similar, although in this case you're given the moles of copper sulfate. You don't need to work it out using G-Mister moles. So I'm given the moles of copper sulfate. And I'm asked to work out the mass of zinc. So again, zinc and copper sulfate are the two things then I put into my table. You can see the ratio between them is 1:1. Therefore, the moles of zinc is 0.043. I'm told the atomic mass of zinc is 65. So I'm multiplying these two numbers together and I'm getting my final answer to 1 decimal place. So make sure you're reading the question properly. The next question is a little bit different, so I will do this one. So it says, in one experiment, it was found that 4.48 grams of iron. So giving me information about iron, so I'm going to put iron into my table. Iron is just Fe. Reacted with an excess lead nitrate solution to form 24.84 grams of lead. So lead, again, if you're not sure, look at your periodic table, but lead is just Pb. And this question is slightly different because they give you the mass of both, and what they want you to do is work out the ratio and then pick which one of these equations is correct. So I'm given the mass of iron and I'm given the mass of lead. I'm going to need to work out moles for both. Again, if they're giving you atomic mass and they're giving you mass, they're giving you G, they're giving you Mister, they want you to find moles. So Mister for Fe is 56 and for lead it's 207. And then all I need to do is divide to find moles. So for iron it's 0.08. For lead it's 207 is 0.12. So when I've found out moles, what I need to do is get them into a simple whole number ratio. And to simplify this ratio and get rid of the decimals, I pick the smaller of the two numbers, which is 0.08, and I divide both numbers by the smaller number. So I'm going to divide both of these by 0.08. And when I do, I get 1:1.5. Now I still have a decimal. You cannot just round 0.5 up to 2. To get rid of 0.5, 0.5 is a half. So to make a half a whole number, you're going to need to multiply by 2 because there are 2 halves in a whole. So if I multiply that by 2, I get 3. If I multiply the right by 2, I need to multiply the left by 2 to maintain that same ratio. So 2:3 is the same ratio as 1:1.5. So now that I've got these two numbers, I need to look at my balanced equation. And ideally, I want a balanced equation that has a 2 in front of the Fe and a 3 in front of the PB. And if I come here and look at equation 2, I can see that I've got that. A 2 in front of the FE, a 3 in front of the PB. So I'm showing that equation 2 is the correct equation for this process. The next question is similar, but slightly different. You're told you have got iron, 8.40 grams of it, and you're told it reacts with chlorine to form iron chloride. Now there are two different formulas for iron chloride, FeCl2 and FeCl3, because iron is one of the transition metals. You find it in the middle of the periodic table, and sometimes it has a +2 charge, so this would be the correct formula, and sometimes it has a +3 charge, so this would be the correct formula. At the moment, I don't know which of these formulas to use, okay? I'm just going to use FeCl2, but you could pick either at this point. They just tell you you're forming iron chloride, and 19.05 grams is the iron chloride. So again, in both cases, I'm given mass. So in both cases, I'm going to work out moles, and then I'm going to simplify my ratio to see which equation is correct. So for iron, the formula mass is just 56. For iron chloride with Cl2, I'm going to have two 35.5s, so that's going to give me 71, and then I'm going to add on a 56 for iron, and I'm going to get a value of 127. To work out moles, it's just mass divided by formula mass, so I get 0.15 here, and then over here, 19.05 divided by 127, I also get 0.15. Okay, so in this case, when I want to simplify my ratio into a whole number, it's nice and easy. It's just going to be 1:1. And what I'm looking for here is if I go back to the if I go back to the equation, the one that forms FeCl2, are iron and iron chloride in a 1:1 ratio. And if I go back up here to equation A, I'll see that iron and iron chloride are in a 1:1 ratio. So that tells me that A is the correct equation. Now, if you had picked equation B and used FeCl3 and you worked it out in exactly the same way, you would find that the numbers you get for ratio do not match equation B, and that tells you that A is the correct answer. And it doesn't matter if you prove that A is correct or B is incorrect. Either way, you're going to get your marks. I now just want to flick back up to the very first question, which I skipped. The first part of it is fine. You're just given mass. You're asked to find moles, so it's going to be 0.1 divided by 24. In the next part, you're told that you're reacting HCl with magnesium. So I can see from my equation above, if I'm reacting magnesium and HCl, that there is a 1:2 ratio between them. And you're told that you're using 0.5 moles of hydrochloric acid and 0.5 moles of magnesium. And you're asked to show the magnesium is in excess. That just means show me that you've got more magnesium than you need. So I'm starting with 0.5 moles of HCl. According to my ratio, I would only need 0.25 moles of magnesium because I need half the amount of magnesium. But instead of giving me half the amount of magnesium, they've given me an equal amount of magnesium. Therefore, I've got more magnesium than I need. Therefore, magnesium is in excess. So this calculation is all you would need to show.